That's PDS, right?
So do we have? Yeah. It's not first. Sorry. Let's look at the comment. Nothing. No, I don't. We do not. Good enough, right? Yeah. Okay. Hello, my name is Hans Hatra. I'm one of the workshop co-chairs, together with Ricardo, who refused to do the introduction. So I'm doing it now. We have a tight schedule. So this year we only got 1.5 hours for the workshop, unlike past years. So let's directly start. So for the first, for the speakers, I have read you should stay here in this area, in this pink area, for the camera. Don't forget that everything that you say is recorded and broadcasted. And we are also passing around this blue sheet where you write that you have participated with it. Okay, so I would like to. Can you go to the next slide? I would like to ask the first speaker, Pedro, to start. Since we have only 1.5 hours, please be very careful with how much time you use. We calculated 20 minutes per speaker. 20 minutes including questions. Including questions, yeah. So the more questions you want, which is actually the interesting part, right, when you come to an IETF meeting, the shorter you should make your speech. Okay.
Okay, thank you.
Please introduce yourself.
Okay.
Yes.
So thank you for introducing me, and also Ricardo for this opportunity. Do you think the microphone is okay? Yeah. Or I need to? Yes. Okay. So I'm Pedro Eleni Zoleni. I'm the new PhD student at the University of Antwerp in Belgium. My advisor is Professor Steven Latre and also Lisandro from Brazil. This work I made in my master's with Lisandro and Jürgen at the university in Brazil. And it's about interactive monitoring, visualization, and configuration of OpenFlow-based SDN. So Ricardo can. So basically, we considered that SDN is based on 4 fundamental principles. The first one is the network control and forwarding. Forwarding planes are clearly decoupled. The second one is the forwarding decisions are flow-based instead of destination-based. The third one is the network forwarding logic is abstracted from hardware to a programmable software layer. And also a control element is introduced to coordinate network-wide forwarding decisions. And also, SDN has a flexible architecture with 4 planes, the application plane, the control plane, the forwarding plane, and also the management plane. The application plane comprehends the network applications and services. The control plane comprehends the SDN controllers. The forwarding plane comprehends the set of simple forwarding devices. And the management plane comprehends the management solutions, for example, solutions to resource allocation and monitoring device status. And nowadays, the most relevant SDN implementation is the OpenFlow protocol. Because of these principles and its flexible architecture, SDN reduces or even eliminates some traditional management problems. For for example, enabling network configuration in a high-level language, and also providing support for enhanced network diagnosis and troubleshooting. Activities as monitoring, visualization, and configuration are fundamental in the management context, and they can be considerably different from traditional networks. I mean, for instance, SDN controller behavior can be customized by a network administrator, and these customizations might impact on resource usage and traffic forwarding performance. And some proposals argue that a centralized controller creates bottlenecks at the control channel, and also another proposals like DevOflow and Defane attempted to alleviate these bottlenecks by distributing the control logic of OpenFlow, but remains a question of how OpenFlow control message can be used without affect the network performance. And moreover, there are other SDN proposals that use the monitoring information to automate tasks. I mean, to reduce control traffic overhead and also protecting the network. But in what proportion the SDN controller behavior can affect both resource consumption and also traffic forwarding performance? To best of our knowledge, there's no solution available to integrate the monitoring information with interactive visualization and configuration tools for SDN. And with such a solution, the administrator could better understand and interact with SDN. So basically, we have two contributions. The first one is the control channel analysis, that we quantify the overheads imposed by OpenFlow control message. And then we propose an interactive approach to SDN management through monitoring, visualization, and configuration activities by including the administrator in a management loop. So basically, I will start with the control channel analysis. Yes. So in our control channel analysis, we quantify the overheads imposed by OpenFlow 1.0, and we use the controller forwarding behavior implementation in a campus network scenario. We analyzed the control channel load metric related to the installation and monitoring forwarding rules, and also resource usage related to active and idle rules. And it's important to emphasize, Ricardo, that is an idle rule is considered idle when its counters do not change between two monitoring poles. These are all OpenFlow 1.0 control messages. We only studied these four subtypes highlighted. The modify state, send packet, and packeting messages are related to forwarding rule installation, and the read state messages are related to monitoring. Ricardo? We only studied these four subtypes because they represent more than 97% of the messages exchanges between controller and forwarding device, and more than 99% of the overall control traffic, because we use the forwarding behavior without changing its implementation. And this is a simple example of forwarding behavior and rule installation between a source host and a file server. And supposing that the controller already knows the source host and the file server, the first step is the source host sends a data packet to the first switch in the flow path. This switch checks if has a forwarding rule that match with the header fields. If not, the switch generates a packeting to the controller. The controller receives this packeting. The controller calculates all the path and sends modify state messages to all switches along the path, except the switch that originates the packeting. And then the controller send a modify state with a send packet to the switch that originates the packeting in order to install the rules and all the switches along the path. And then the message goes to the file server normally, and the next packets goes without requesting the controller. Okay. So regarding the scenario of study, we emulated over Mininet our campus network scenario. with 230 hosts, 11 switches, one web server, one video server, and one centralized fluid-like controller. Okay. Regarding our workload, we emulated based on several previous studies. We model user traffic profile that dictates the size of requests and the responses, also the reading and the watch time for the video server and the file server. And we fixed the polling frequency in 5 seconds during the 30 minutes of experiment. And we decided to vary the idle timeout configuration that indicates when the forwarding rule can be removed due to a lack of activity. Okay, this results show that a single factor configured in the controller can make a huge difference in the amount of rules installed in the network. This chart illustrates the amount of rules installed in the network and which of those are idle given a idle timeout configuration. And it's clear to observe when we set this idle timeout to 120 seconds, we have more than 1,000 rules installed in the network, and being 77% of these rules idle. The reason of this amount of idle rules is because most of users are request a web file, do a web request, and then it's short-lived requests, and then the rule remains more time idle. And this other charts shows the control channel rate and the packets processed per second along the idle timeout configuration. And we have send packet, modify state, and read state requests going from the controller to in that direction from the controller to the forward devices, and the packet in and read state replies messages goes from the devices in the controller's direction. And the height of each bar represents the control channel load and the packets processed per second in both directions. So we can see that if we set the idle timeout to a lower value, we have more traffic related to installation process. The message that are exchanged to install more rules are more often, but the overhead imposed for monitoring is lower because we don't have too many rules to monitor. And if we set to a higher values, we have more overhead related to monitoring because we have more rules to monitor, but we have less installation process in this case. And this means that the administration needs to watch over this parameter in order to avoid some bottleneck because it's correlated. So now I'll present our approach. Go, Ricardo. So this is the SDN architecture along with the components that we added on our approach inside the management plane. We have basically two main components: the monitoring manager, the visualization manager, and the configuration manager. By creating a loop with the administrator interactions. The monitoring manager is responsible to retrieve information about the network and store it in a local database. And to do that, the monitoring manager communicates with the controller through the management interface, and its module is the infrastructure synchronizer. The visualization manager aggregates data provided by the monitoring manager and also provides an interactive visualizations to the administrator, to the graphical user interface. And its modules is the chart visualizations and the statistics processing. The last one, the configuration manager is responsible to check and configure SDN-related parameters on network controllers And to do that, this component communicates with the same management interface to access the data to access and change the data from the controllers. And its module is the floodlight adapter in our case. So this is our interface, the interface of our prototype. We have configurations possibilities, also topology view with node information, and also interactive charts that represent the graphs that I showed previously. And we evaluated our prototype by simulating some administrator configurations. These charts represent the amount of rules and which of those are idle during the time, also the rate of control channel load, and the packets processed per second. So we can see in the first change that the administrator is to increase the idle timeout to 60 seconds, and this configuration implies in more rules installed in the network and more idle rules also. And we can see that also the traffic that goes to the controller, traffic related to the monitoring also grows, because this traffic is also related to the amount of rules that we have in the network. But we can see the traffic that is related to the rules installation decrease, because the installations process is more rare in this case. So then the administrator try to decrease this traffic that goes to the controller by increasing the polling frequency, for example, to 40 seconds. And then we can see that the traffic that is related to monitoring decrease, but we can see also that we have a precision loss. We cannot identify anymore the idle rules because the monitoring polls are too sparse. And it's also interesting to see that in the last configuration, the administrator tried to identify other rules again, and he decreased the polling frequency to 50 seconds, and we can see that we could again to identify other rules in the network. So through our control channel analysis, we identified that a single factor configured at the controller can make all the difference on both resource consumption and also control channel load. And through our prototype, we were able to retrieve statistics about the control channel. That is a feature that most SDN approaches do not consider. Also, we allowed the administrator to interact with SDN through the interactive graphs. And based off these interactive visualizations, the administrator could be able to identify potential issues and change configurations in the SDN. So the major challenge of our work was to deal with the control channel statistics that in our case, there are different controller implementations nowadays, and currently there's no standardized interface to access this data and controllers. And we argue that such a standardization may foster further SDN solutions regardless of applications and controllers and forwarding devices. So these are the references used in the presentation. And thank you for your time, and I'm open for questions.
Hello. So we have a few minutes for questions. If there is any from the audience, please just walk to the microphones. Otherwise, I shoot the first one. So, Pedro, you were talking about different controllers implementation. In a campus network was your test bed, let's say, where you deployed your prototype or your simulations. But how would you imagine OpenFlow network deployment using different controllers? Why would an administrator try to use only a single controller? Is there any case that it's possible?
Yeah, we only consider only one controller, but if we consider more than one, we should implement more drivers, because there are different implementations and we could not address. For example, we used Floodlight or modified Floodlight. If you want to use POX or Ryu, you need to implement a specific driver to retrieve this same information to use in our prototype.
Okay. And about measurements, do you envision or do you use any sort of traffic measurements that the OpenFlow controllers provide, or the OpenFlow switches provide actually, like at the table, at the forwarding table, they are supposed to do some per flow measurements, number of packets, number of bytes. Did you ever use those? Do you have any consideration on that?
We only concentrate on control traffic, and the counters that OpenFlow provides to us is only data traffic. We only use to identify if it's an idle rule or not, but it was only this, and because we focus on the control traffic only. Yes.
Okay, thank you. If there are no more questions, we can quickly move to the next presentation then as well. Thank you, Pedro, again.
Thank you.
So, our next speaker is Jan, right? Jan Pluskal from Chestnut. And he will speak on the detection and analysis of the fraud attacks.
Thank you for the introduction. Good afternoon. My name is Jan Pluskal. I am a PhD candidate at Brno University of Technology, and I'm also employed at CESNET, which is an NRAN provider for Czech Republic. Today, I would like to speak about detection and analysis, in this case of a SIP fraud attack, but it can be generalized on any other kinds of attacks, and on 100G technology, Ethernet, which have been developed also by CESNET and in cooperation with intrusion detection system, the NIMIA. So let's start with the introduction and the motivation. We employ the traditional system of flow-based monitoring. This is very beneficial because of its security analysis, performance evaluation, accounting, and so on. But it has some caveats, like if you want to do some forensic analysis, you want to learn from patterns that are already detected, or improve your techniques, or verify if the attack is true positive or false negative, etc. It can be done very poorly with only flow-based analysis. So our goal was to speak up. Okay, is it better? Okay. So our goal is to automate the light capturing on demand and to include some additional part of capturing from so-called technology, the time machine. So altogether, we would like to combine the combination of packet capturing with flow-based analysis principles. So this is the basic. We have Ethernet, flow computation on some probe, and we can work with that. So this is the typical scenario that's employed on networks. So we extend this to SDN. We call it software-defined monitoring. This is our concept. We create a special network card on 100G. It includes the FPGA core, and it is capable of filtration, modification, and computation of the flows. So using this technology, we can offload the computation of IP fixed flow to the FPGA, and we can spare some resources on the combination hardware that we can utilize for other computations. So on a highlight principle, we have the monitoring probe, the SDN. We want to observe the flow data that are generated. These flow data are enhanced by some application identifiers. For example, with the SIP, the session initiation protocol, we've enhanced it by URL and so on. And we want to analyze and detect these network incidents, and we want to give the feedback, the alert, when the incident is detected back to the monitoring probe with the SDM and start the full packet capturing. So from now on, the full packet capturing will be initiated, but if we want to observe the beginnings of the vector attack, we need the data from the past, so the time machine technology. So our real-time approach, we've included with the firmware implemented on the card, the live capturing. So getting to the time machine, we've looked at the technology or the proposal based on Cornexel and Paxson's building a time machine for efficient recording and retrieval high-volume networking traffic in 2005. They use the storage of packages on hard drive, which is nowadays somehow obsolete because we can't store so much data on the speeds on hard drives, and they use it for long-term storages. The cleverness was that not all packets have been captured, but only the beginnings of the flow, because the beginnings of the flow containing the headers or the vector of the attacks, and they can be further observed and are the most interesting for us. So our modification to the SDM time machine, we use the principles, but enhance it by storing the traffic or the beginnings of the traffic into RAM, which is much faster. We use technology for 100G. We've implemented the software ring buffer that gives us as much space as we need, or it's given in the RAM, and we store only the first n packets of each flow that can be stored as long as possible, always with the RAM. So given this, when the alert is reported, we are able to start the full packet capturing and retrieve the data back from the past from the ring buffer. So in this way, we can look like in the past. So we've enhanced this graph or this diagram with the time machine. So the measurements or what we have done with this technology. We've tested on detection of vertical horizontal network scans, detection of communication tunnels in DNS, and the SIP fraud attack or the guessing of SIP dial plan with poorly configured network private branch exchanges. So using the SDM with time machine, we can get evidence and verify the detected incidents from the past. So you might ask, are the N packets enough? So we've done some monitoring of our network, and we find out that with the aggregation, is the red line. If you look, or if you capture only 10 packets, you get more than 90% of all flows, of all communication in the flows. And the rest, 10%, is the data that are not so interesting for you because it captures or it contains very big payloads that are not interesting for this analysis because these attacks also are the short or have short payloads. So if you look also on the 10, or we choose decision threshold at 10 packets, we can see that we eliminate almost 90% of data that otherwise would have to be captured or stored in the RAM. So with the decision threshold 10, we only store about 10% of all data that needs to be captured or given in the time machine. It also differs on different L7 protocols that's used, but in general, it's this. So the machine that we've used for testing, it contained 2 CPUs, overall 24 CPU cores, about 64 gigabytes of RAM, and 80 gigabits older version of SDN capable card. We used 56 gigabytes of RAM for ring buffer, and we've captured on full utilized link speed. We stored only 10 packets of each flow, and we observed that we could store about 15 minutes of the traffic. So in this configuration, we are able to see back 15 minutes of the traffic. So we have 15 minutes to detect the incident, start full packet capturing, and retrieve the data from the past. But these numbers are very dependent on the characteristic of the networks and traffic volume distribution, etc. So it might differ. So some other measurement on the configuration, how much time you can capture or you can see in the past if you change the threshold for captured packets. So starting with 2, you have about 8,000 seconds, but it's unusable most of the times. So we find out that the most reasonable threshold is around the 10 minutes. So with this threshold, we have the most success rate in detecting of the incidents. So let's look at the use case of SIP fraud attack. The basics of this attack is a poorly configured private branch exchange on some company. Using this technology on our network, we do observe around 4 of these attacks or different attacks per day on our networks. So as you can see, it might be interesting for some companies to know that they are vulnerable for this kind of attacks. It's based on poor configuration because some administrators just forget to exclude public internet from the private prefix calls or improper configuration of authentication. So detection of this attack and this attack scheme. We have an attacker computer that's infected by malware or under the control of the attacker. We have the private branch exchange that's connected to PSTN, which is the telecommunication services. The attacker just rents a paid service. That's the premium number that is very expensive to call. And the attacker starts to guess the secret prefix that you include before the actual number if you want to call outside of your company. So when the attack is successful, attacker just starts the call and withdraw the money from the paid service. So the SIP, session initiation protocol, is text-based protocol. It contains just a few messages, and these messages can be parsed on the computer or the combinational hardware that's used for the capturing or for the probe. So we just extend the IPFix that we use for NetFlow exports, and we include the URI from the invite messages, and we observe the codes that are retrieved. So when the attack is successful, the server results with or return the message 200 OK, and the call can start. So typical attack looks like this. Attacker sends very large amount of invites with different prefixes. The server returns this message, and when the attack is successful, you can observe this pattern. So prefix guessing, you can imagine in this way. This is the private number, prefixes, and the attacker tries to guess these prefixes. So how we can detect this attack? From point of network architecture, we just need to be in the middle, to intercept the communication, monitor the probe, export IPFix, and using our own system that Cessnet have developed, the NIMIA, the intrusion detection system, which is based on flow processing or stream processing of net flows. It can detect these kind of attacks and the YP fraud and report to the supervisor and give the feedback to the monitoring probe to capture all the data. So this monitoring module has 2 parameters: maximum prefix length and the threshold on which it can test that this is the attack or this is not the attack. So you can imagine it like this. You have some domain, some number, and a lot of subtrees with the prefixes that are tried to be called. So this is the typical pattern of this attack. Our monitoring or the visualization, so how we can conclude this tool, the system. We've used the open source network forensic analysis tool, Network Detective, that have been developed on Brno faculty or Brno University technology. This tool is able to process PCAP files, extract some information from application layer, and it's mostly used for network forensic analysis. So it can operate with large amount of L7 protocols, and it can be easily extended. So for the visualization part, we've implemented into this tool to be a monitoring center or the overview. And this is the architecture that the administrator could see when he deployed this technology. You can see the process of the monitoring or the detection of the attack, the suspicious IPs, transfers of the PCAP files, etc. From this table, the administrator could see if the attack was successful or filter the communication and find out if it's really the attack or not. So this tool also generates the prefix trees, so you can easily see if this is the false positive or false negative of the attack. Also, it provides some additional information like performance statistics, number of frames or bytes transferred up, down, statistic on TCP, if there have been some packet losses or some other information, distribution of protocols on all layers, etc. Sometimes it might be useful to see some packet charts to detect some kind of attacks. And of course, the last functionality, the Wireshark-like approach to see the inner of the packets. So, conclude this presentation. We've developed the technology to monitor 100G. We've extended the flow records of the application identifiers based on, or extension have been implemented into FPGA. And the present system provides flow records, full packet capturing on the 100G, and it enables you to see the history of the communication from the point where the attack actually occurred on the network and to bridge the gap before the detection. So you get all the data in the capacity. So thank you for your attention. If you are interested, you can see our project site, Laboratory, or follow us on Twitter or so on. So thanks again, and the questions?
First, nothing.
Alexander Lemin. I'm sorry, I'm not a big expert on SIP, but obvious case of the padding attack on your system when you pad with unimportant data and then the attack vector passes through undetected. Do you have anything in plans to avoid that, or is it your system even susceptible to it?
Well, it would depend on the monitoring mechanisms of the intrusion detection system, if it's able to go with this kind of attacks or not, if it's detectable from the extended flows or not. I'm not aware if we tried this system against this kind of attacks. We've mainly focused on the most common attacks on our network and to provide us the feedback if we are actually able to monitor or detect this kind of attacks actually, and if the detections are true positive or we are just observing something that isn't on the networks. So to your question, I'm not aware if we tried this kind of attack.
Okay, thank you for your answer. Let's have a conversation afterwards.
Thank you.
Geronimo from the Florida International University. I saw that you use a network tab. So it's a way for you to monitor the communication. But do you guys have any plan to start intervene in case you see an attack, like close a call?
Thank you for excellent question. We are currently developing a solution that will be able to filter the communication and divert the traffic that contains the attack or just ban it or so on. So for now, we are developing the solution for this technology, and it should be available, I think, in December this year.
Okay, thank you.
Thanks.
Hi, this is Soumya here. Very nice presentation. So it's on the same lines on what he has asked. So the tap device would relay the packets from the incoming NIC to your device, the FPGA. So will it have any effect on the throughput?
No, it have no effect on the throughput. It's just this technology is just a passive monitoring. The active part, it's in development.
All right. So is the FPGA also able to classify any metadata related to VMs or containers which may be provisioned in this bare metal machine?
Yeah, well, this technology can be tested on virtual machines. So not on the 100G, but you can deploy it on some smaller networks, and all the tools I've presented are open source. So we don't have any container that can be deployed, but with the reasonable amount of work, it can be deployed on your testing environment.
Sure. So no communication with the hypervisors as well, right? No configuration or anything coming from hypervisor where you can classify.
No.
Okay, sure. Thank you.
What's your name?
Soumya. Yeah, my name is Soumya Dikshit. I'm from Cisco. Yeah.
Thanks for the question.
Any other questions? No? You? Okay, we still have time to, no? Okay, I have one question. When you showed that the statistics about how many packets you would need for the different protocols.
Yes.
Yeah.
Related to the flow size.
Yeah.
Yes.
I think you just said that you cannot detect the protocol, right, or online, so you cannot say you want different number of packets for different protocols.
Well, we can detect the protocols based on some primitive, as far as like the port number,
Okay.
but for now, nothing so much intelligent like machine learning method or something.
Okay. Because I was asking because in SSH I see that there's a big jump at 11, right? So it would be.
Yeah, it's just detected on port 22. So the identification of the stage.
Yeah. Okay, thanks. No questions? Okay, let's thank the speaker again. I would like to ask then the next speaker to come to the. Oh yeah, okay. What is this, Christian? Sorry, Christian Varas is the next speaker. Yeah. Sorry, it was our fault.
Okay.
Okay.
About to escape the whole thing.
Oh.
Okay.
You have your.
I sent to your email my presentation. Otherwise, I can use my laptop.
I can open your presentation here, but the only problem is that we don't have synchronized.
Okay, then we still have time. No problem. Okay. So I use the time to ask a question. How many people are subscribed to the NMRG mailing list? Raise your hand, please. Okay, next year I want to see more hands. No, so just joking. So if you're interested in the work that NMRG is doing, which we are representing the measurement for management part, which is not, of course, the entire NMRG. Here, actually, we have one of the NMRG, what is your official title, actually? Chairs. Laurent. So please feel free to subscribe to the NMRG mailing list and to join other NMRG meetings, at other IETF meetings, and to also join the discussions. Thanks. Okay.
Hello, everyone. My name is Cristian Varas. I work for Speed Checker Limited, and I wanted to talk to you about an experiment we did together with LACNIC, measuring connectivity in South America and Caribbean. So a little line out. We want to talk about the challenge of measuring the region with the already available RIPE Atlas, for example. There are not so many probes there, so I want to tell you how we overcame that problem. With software probes, I want to talk to you about the experiment, how we define connectivity, since we don't have a standard definition for connectivity. So we defined there, and I want to talk about the results and discuss a little bit about that and what we find after doing these measurements. Okay, so the Latin American and Caribbean region doesn't have too many probes in comparison to other countries in the world. We can see in this is taken from the official site of RIPE Atlas, and the country with the most probes is Brazil, a giant country with only 56 probes, and the line down there shows a very pale blue color, meaning that the percentage of probes covered by that country isn't too high. In this case, 0.6% of the total probes of RIPE Atlas And if we compare with the next, with the rest of the world, we can see, for example, the United States and Germany, they're both colored with dark blue, meaning they have a high percentage of probes being available for measurement. And we can see the region in Latin American Caribbean is either pale blue, which means a very low percentage, or yellow, which means no information or no active probes. What we did to overcome these problems is SpeedChecker has a measuring network software with software probes called Probe API, which through an API we can control measurement probes and gather results and do stuff that's it's not available with other measurements. And since they're software probes, they're easily to spread and to install because they're not a hardware that people has to take home and install themselves. And they're running in Windows computers, real users' computers. So they have the advantage of easy deployment, but also the disadvantage of they are very volatile. They appear and disappear all the time. So we have lots of them. So we need lots of them to be able to make reliable measurements. And they work using synthetic traffic. So we can see in this graph a little comparison about Atlas and Probe API. Atlas is the lila color to the left, and different ASNs. So the vertical line are just different ASNs we chose to compare, and they're very highly populated ASNs in terms of users, but not all of them are very well covered by either not Atlas or Probe API. For example, if we take the top ASN, we have 46 probes in that ASN from Atlas and 886 active at that moment when we took the screenshot by Probe API. So it can show, this can show us how we can overcome these measurement problems with some software probes and what we did in this region using this kind of measurement method. Next one. Like I said before, they are highly volatile. That's why we require a high number of probes than normal to make reliable measurements, because they appear and disappear as normal users open and close their laptops or computers. And monitoring from the user's perspective, yes, lets us detect problems that otherwise aren't really easy to see because of the vantage point problem in measuring networks, that depending from where you're measuring from, you will be able to see some things happening or not. Like in the next, in this case, we can see if we are monitoring from inside the network, from the centers, from the data centers, or from servers or whatever. We can monitor a website which will tell us that it's okay, totally okay, or from other users even it will be okay. But if an ISP has connectivity problems or has an outage, then the only way to detect that is from that perspective. And that's one advantage I want to show you from using this, which can be, of course, it's not better or worse than other measurements. It's complementary because it has its own advantages and disadvantages. So we are going now to the experiment itself. We were sending between probes and servers in different countries in Latin America and Caribbean, 200 ICMP pings over 12 months, over 21 countries. The geolocation information was taken from Mozilla and MaxMind databases. Yeah, and each measurement were like 10 pings, so to say, and we took the best out of them to make to calculate our results based on the best available connectivity, the round trip times. And after getting the results, we grouped the countries. Like just observing the results, like clusters emerged very. They were very evident to the eye, and so we can say after grouping the countries, we were able to define connectivity of them using these three measurements, like the number of clusters found, how these clusters relate to each other in terms of connectivity, how the latency between the countries in this cluster is, or outside the cluster, how the connectivity is. So we have here on the upper side on the left, we have the graph we built. and to the right, the map corresponding to the graph. For example, if we take the cluster number 3, Argentina, Brazil, Paraguay, and Uruguay, we can see that that cluster internally, like between Argentina and all those countries, they have a very good connectivity, 143 milliseconds average. But to the outside of that cluster, like going to other countries, we have problems, not problems, but higher latency times. Or the cluster number 2, which is Chile, Bolivia, and Peru, they have really not too, in compared to the other clusters, the internal connectivity or external connectivity isn't really too different, and it's not very well connected to the region in that aspect. And if we observe cluster 0 and number 1, we can find that between them, they have very good connectivity, and their boundaries aren't very evident in that sense. We can also consider them one big cluster, but at the same time, they have some differences that let us differentiate them. So to the rest of the region, they have higher times, but between those two, between 0 and 1, they have only 157 milliseconds latency in average. So those are fairly interesting conclusions you can say to how the region is behaving in terms of latency. And yeah, this is a simple explanation of the graph, and I think I'll explain that already. Yes. So I already told you this about the results. The class number 2 is kind of weak in itself. It doesn't really connect between even internally or externally. Maybe only inside the countries the connectivity is good, but between those countries, Chile, Peru, and Bolivia, the connectivity isn't very good. Like I told you also, like cluster 3, it has very internal cluster latency values, but outside the cluster, it isn't very good. So the countries between them, they are very well connected, but to the rest, it isn't very well. And like I told you before, clusters 0 and 1, can you go back two slides? Yeah, 0 and 1 are very well connected between them. It's not a very clear cluster in that sense, but to the rest of the countries, they have higher latency values. And yes, we can go back to 3. Exactly. So we followed the same procedure to detect bad connectivity, or so to say, we use the same value of round trip, but we use the inverse to construct the same graph. And so it's not we weren't taking actually the worst results, but actually comparing the least good of them, like where we're always taking the best ICMP measurements, and then we took the inverse of that, and we can construct the graph based on the least good results. So bad connectivity was detected between Argentina and Chile, which is surprising in some sense, because they have a very big frontier, very large, but at the same time, if you think geographically between Argentina and Chile, there's the Andes in between, and it's not as easy to lay a cable between going through the Andes, which are very, very big mountains. Colombia and Venezuela, they don't have a very good connectivity between them, and Brazil and Peru. So, mostly, it's because normally they're preferring, we think, it's sea cables are being preferred to connect than land cables, and probably because the geography of the region isn't really that favorable for laying earth cables. That's why we think that ocean cables are being used, and that results sometimes in very long trips for things that could have been a lot shorter. Next one, please. So yeah, we're coming to the end. Just 3 open questions we have after doing this little experiment. Is there? Can we summarize? Does anybody have an idea if we can summarize these indexes per country or per cluster, so we can, in one number, we can compare them, like how good it is internally, externally, or between them? Is there any idea to get to that point? Maybe are there physical connections that in those countries are not being fully used, and there's like infrastructure that's being misused or underused? or maybe our measurements are escaping some links. Just we leave that with those questions. There's sometimes technically not too easy to answer, but I would like to present them to you. And I think that would be all. Thank you very much.
Thank you, Christian. Christian.
Christian. Yeah.
Christian. Any question from the audience? Oh, that's a lot.
Drew Taylor from Comcast. Thanks for his presentation. It's very good to see. So I think one of the big selling points behind Ripe Atlas is the hardware is very consistent. So is the software stack.
Yes.
So I'm kind of curious, have you done any studies to see how that's affecting your data?
No, not really until now. We've been concentrated in expanding the network and making the probes as functional as possible, but quality assurance on measurements is of course an important task we have to take into account. But of course the hardware running the probes is very diverse depending on everybody's computers or Windows installation, how healthy is the installation itself. So yes, it's very dependent on that. Yeah, you're right.
Thanks.
Well, Geronimo from Florida International University. I have two questions. The first one, have you considered testing the connectivity, the last mile connectivity, for example, to understand if that user is using Wi-Fi that could easily add 20 milliseconds or using wired connectivity? And the second one, it would be good to have a cluster in the US. I know that you're monitoring Latin America, but it looks like at least between Brazil, Chile, and Argentina, all of the traffic intra-cluster is going through the US because 143 milliseconds is a lot.
Yes, yes. Yeah, I think there's a lot going through Miami or something,
Yeah.
And that's, big. Yeah, it's a bit stupid from the sense, but that's how things are being done now. What was the first question again?
About the last mile. For example, if you have two users pinging between them, each user is connected to a Wi-Fi, you have easily 40 milliseconds just for the last mile.
Yes. Yes.
So the probe test is the connectivity to the first router to understand if it's Wi-Fi or wired connectivity.
We haven't done that part. We are assuming like the user's point of view, no matter what is between them and the server, because there may be more than one Wi-Fi in between. There's an undetermined number of things between them. So until now, we haven't done that part. But yeah, it sounds a very interesting thing to do. Of course, like to get that part of the charts.
Okay, thank you.
Thank you.
Hi, Yoshiro Yonea from JPRS. My question is about the software probe. How did you deploy your software probe in LAC area? And my another question is it available to the public? If you have any website, I'd like to know.
If we have what?
If you have any website about software probe, then
Yes.
I'd like to know.
Yes, we have. You can communicate with speedchecker.xyz, and you can download your own probe. It's a speed checking software, which users download, and most of the time the software doesn't really do much than check your DSL speed, and at the same time the software is available to us as a probe to make measurements. Most of the time the software isn't doing anything, but when it receives a measurement command, it will measure very shortly, and we deploy that way. We offer the users to measure the DSL connectivity, and in exchange make their computers available to our network.
Thank you.
Mm-hmm.
Alexander Azimov, Curator Labs. I think you know that RIPE is a non-profit company, and RIPE Atlas is also non-profit. And so if you're running RIPE probes, you are getting access for your measurements for all RIPE probes. Do you provide such service too?
Can you rephrase that again so I can?
If you are running RIPE Atlas probes, you are getting access for your measurements to all RIPE Atlas probes. You are getting credits and you can use them.
Mm-hmm.
Do you provide some kind of such service for users that are running your software? So if tomorrow I will run your software, will I be able to create measurements not only with my computer, but also with other probes that are connected to your network?
Yes. Right now, we're not offering that kind of exchange, but it would be very interesting if people are interested in measuring themselves. We are open, of course, for research to use our platform for free in that sense, but like the users of the pros themselves don't have a direct exchange of credits like you described. Mostly, you can make an account with us for free and use to a certain point the measurement system. But such a system as you say, we haven't implemented that yet.
But is it possible to customize these measurements, or it is only an opportunity to make some ping request or something like this?
Yeah, some what?
Some ping.
Yes, every probe has very different measurement methods. We can make page load measurements, like we're using a real instance of Explorer or Chrome. The probe spawns an instance, loads the page, and it kills itself then. And yeah, we can download single objects or ping. And in there, customizable in the sense that they're available either as a ready product we have, like with a GUI, or as an API that the one they used in LACNIC to make this measurement, which they as an API you can code. It's available through Mashape. So you can use the code in Java and PHP, or you can interact with the API using almost any popular language.
Okay, thank you. I think it will be very good if you will take RIPE as an example. It also will provide your users something in exchange. Thank you.
Thank you. Yes, thank you.
Yeah, Humberto, ISOC IETF fellow. So I don't know if you are aware, but in Brazil, the NIC.br is heading a project to perform measurements. The project is called CIMET.br. So the idea is basically do essentially the same, but using the end user to install the application and perform measurements from the desktop or from the mobile or whatever. So maybe as a suggestion, maybe it would be nice to get this data. I think it's open to the public. It's much better to use this data than use the RIPE probes. And another comment is that some answer to the questions you put did. I think there are some operators in Latin America. I remember from Internexus, they have direct connection from Brazil to Colombia. And I remember another one which has connection from Sao Paulo to Santiago, passing through Argentina. So maybe it wasn't included to your study. So you could consider this.
Okay, thank you.
Yeah, Giovanni, I'm the next speaker, actually. I work for SIDM. So you did your measurements using ICMP, right? If I'm
Yes.
Correct. There's a lot of criticism in regards to ICMP because it's heavily shaped. Sometimes it's a lower QoS.
Yes.
You know, this criticism problem. So have you considered using other protocols instead and compare the results?
Yes. Like personally and internally at the company, this is a study done by LACNIC, and we're presenting this as a cooperation. They had their made their own decision of using ICMP, but normally we use time to first byte using HTTP directly because it's the protocol we're using. So we measure either a 1 byte file, downloading it just like that, or just we measure the time it took to download the first byte, and that's mostly equivalent to ICMP, but using the HTTP stack.
Right.
Yes.
Thank you.
Last one, please, Bert Wijnen, Huawei. I work with RIPE NCC and working on the RIPE Atlas project. So it's good the work that you did, but if you guys, you know, in Latin America are interested in more probes, I'm sure they're willing to send more probes. You know, if you need contacts, I'm sure you have contacts, but if you do need more contacts, please feel free to check with me.
Yeah.
Please let me complete that one. I am actually working also with RIPE Atlas as ambassador for Brazilian region. So if you live in South America and you want probes, I have them.
Oh, nice.
I also, I do agree that RIPE Atlas also have a worldwide coverage, but it's nice to always add diversity to measurement infrastructure, even more when it goes to the developing regions or poorer regions of the country or of the world where it's difficult to get the RIPE shipped to. I would like just to complete the question session with one question. Is your measurement running over time, or are you do it once and stop, or is it running for example, a year already?
It was done for a year, and it was programmed to measure in regular intervals as how you want, using the any time controlling algorithm you want if you're using the API. And yeah, it's not continuous monitoring. It's normally one test, and you can repeat it as much as you want.
Okay, so I would like to suggest perhaps for a talk for an NMRG next year. If you can see the impacts of social and political decisions that are going on in South America. I'm from South America, so
yeah,
I know that there are these problems going on there quite often. If you can see from your measurement framework the impacts that it has on the connectivity of people, it's always nice. So we see papers being published about Cuba, about China, about other places where we have one RIPE atlas, two RIPE atlas, but they can already see some nice characteristics there. So that would be awesome.
Yeah, thank you.
Okay. Yeah. Thank you, Christian, again. Let's thank you.
Thank you, everybody. Bye.
Our next speaker is Giovanni Mora from SIDN Labs. Do you need my computer, Giovanni?
Oh, yeah. Yes,
Yeah? Okay.
That'd be great.
This is not my computer, this is Christian.
Yeah, it's good to see. There's a lot of people here today. It's pretty nice.
Done a good job. Yeah, so I think I can start, just give you some context. So the work I'm going to present here is not, say, purely academic. This is a paper we published at the APWG eCrime conference on the industrial track. So it's a bit mixed. It's like more hands-on, practical than research questions. So this is a paper we did in the team there in SIDN. We have a big data platform for DNS traffic. And this paper shows a couple of applications what things you can do quickly with that. Should go next slide, please. Okay, just to give you some context here. What do you do if you're? I think how many people here actually have a big data problem, like volume of data that's like you have to analyze these things? Can you raise your hands for those big data analysis here? I mean, big data is very vague, but yeah. There we go. All right. So, I mean, if you have like terabytes of data, and especially PCAP files, you have to analyze this thing. You know what a nightmare is, or the cost you're going to have to do that. You need to do that in an efficient and a cheap way. So the engineers from the company that I work for, they start to using stuff from other disciplines, like the data engineering people, to optimize that and bring that to that networking community. And they call this Entrada. This is a product that's built on open source code. I'm going to give the details later on. And what it does on top of that, it is designed to ingest DNS traffic. I work for a company that does .nl, the top level domain of the Netherlands. So we collect all the authoritative traffic and store in our cluster for analysis, for research purposes. So there are a couple of things you can do. You can put on a SQL table if you have this terabytes of data sets, and things that usually don't scale. So you need something that really scales, and once you need more hardware, just put more hardware on that and throw more hardware, you keep the speed. So that's, next slide, please. And so that's pretty much what they've done that. Since we need this response time and interactive times, they build his own thing. Next one, please. So Entrada is basically
an optimized format and a platform for performing data analysis on internet traffic. I think Roland also uses some of the same architecture, but not in Entrada, but like Hadoop and Impala and the same file on his project there too. The thing is, you can analyze the equivalent of 50 terabytes of PCAP data in a small 4-node cluster. It's a tiny cluster. And for example, if you need to know what is the number of IPv6 packets you had on your network on November 30th, for example, last year, if you would have to find your PCAPs and process all those things and do discounts, or the average packet size is going to take forever, but if you have stuff like that, it's going to be real quick, like a question of minutes. Yeah, or seconds. And yeah, next slide, please. So Entrada boils down to getting the PCAPs, converting that thing to an optimized format, which is Parquet. Parquet is implemented by Apache Foundation, which is based on Google's Dremel file system, which is an optimized columnar file format. In short, if you need to like do a rating on your file, if you want to just figure it out what's the packet size for all your files, for all your packets that is in your network, you don't actually need to read the entire file. You just need to read the entire column they're interested in. So it saves a lot of time. The beauty of this thing, you can query that thing with Impala, and Impala is a cloud data product, open source as well, which allows you to send SQL code to analyze your PCAP equivalent files. So it's very easy for anyone who want to do a data analysis fast as well. Yeah, next one, please. And the thing that they did in the company, they just like wrapped all those things together and implemented a data model to incorporate DNS traffic and to constantly ingest this thing. That's what we call Entrada. And we use this thing now for over 2 years now. We have like billions of queries there, 21 terabytes of data, and it's already converted. And we capture the data from our own service. That's it. Next one, please. We got a paper published at NOMS, which is from this measurement community as well, conference. We just talk about more the details of this thing. So if you're interested, just refer to that, please. And this paper that reflects this presentation right now covers a couple of applications, and I'm just going to focus on some of them here. So we have a page, the first one there. I don't think I have slides for that, but if you check it out, the web page later on, stocks.sidnlabs.nl, we update every day this page using this cluster Entrada with our statistics of our .nl traffic. So the number of countries, autonomous systems, there's a bunch of stuff there. If you're interested, just check it out. It's all public. We also have some stuff on malicious domains, and we're going to cover this ones in bold here. So next one, please. So one of the things we need to do in a company, in the labs, is to use this data we collect to improve both security and performance and stability of the service that we maintain, the .nl authoritative service. And there's a paper from Nick Fimster on IMC 2011, if I'm not mistaken. They figured out that domains that they're using for phishing, typically on the very first days or hours after registrations, they have a peak on the number of queries that they get. And you observe the same for .nl. So, for example, the figure on the right over there, it has an average number of 150 queries or 200. These are domains that were provided by Netcraft that were found in phishing on the .nl zone. So we look at our authoritative servers and you see, hey, how many queries we've seen for those particular domains after the registration. And you see there's a peak, and after 10 days, it really dies down. While the normal regular domains, you have an average of 5 queries a day on the first days, or 3 or whatever. So there's a clear, distinct pattern. Nick Fimster found the stuff and he published, whatever. We kind of went a step further and he run a different algorithm to classify that, came in on top of that, and had a paper on this particular thing. So next slide, please. And what do? You get every day all the domains that were added to our .nl zone that were registered. We'll look for a couple of features, the number of queries, the number of countries, resolvers that are querying that thing on the first day. We run k-means on top of that, and it classifies into 2 clusters, suspicious and normal. Normal. And once you get a suspicious one, we notify our registrars, and registrars are the companies that actually do the registration for us. It's in a pilot stage right now. There's a couple of false positives, of course, because you're trying to identify phishing only from the query pattern of the domains. As is like it's because the phishers usually they rely upon spam to notify their domains in the first day. So you usually have a huge number of queries. But any political motivated website also get this thing. So we are working to improve this, but it's working on a kind of status, a prototype phase right now. Next one, please. This is a project of Marco, who's sitting right over here, I guess. Yeah, it's botnet detection. So there's a particular botnet. We cannot really talk much about it because they figured out the signature for this botnet, and we can detect that one looking at our DNS traffic that we're seeing. There's a couple of, I think, if I'm not mistaken, those are CNC channels, domains that they use, and you kind of monitor the traffic to them. And once we get this thing, we also use Entrada. That's a platform to analyze that. That's the whole thing. We notify what we call, it's a Dutch initiative, which is called Abuse Information Exchange. So it's a place in the federal level that collects information about abuse. It's run by the government. And it shares back with the people responsible for those IP addresses for those autonomous systems so they can clean up the networks. Next one, please. Just a bunch of stud cases. And this is the number. You'll see the time series and the countries that these bots were observed. And we send information with regards timestamps so they can take a look on that. Bear in mind that the way the DNS works, once we see a query on our authoritative service, it might not be the actual client, might be the resolver of the client on the ISP network. So they would have to do a little more investigation on that. Next one, please. And there are these two RFCs that standardize different things, policy and for email security. This try to improve email security in a way to define who can send email for a particular domain and what is the policy once you get email from a different IP address for the domain. And you can actually measure there that the adoption of that using simply SQL queries in our platform, because we get the traffic, so you just run SQL, run over the days, and you see like how this thing is growing. Next one, please. So we have a couple of results here, and you see there's a percentage there's a lot of percentage of adoption in the US. And of course, this is the cloud providers. It means Gmail. Most of people use Gmail. So Yahoo and the cloud providers. That's why you see this is fixed. And where you have cloud, you have this thing. So once they adopt it, that's it. Next one, please. All right. These are the autonomous systems where they're located. All these things can easily be done as well. Next one. Yeah. So I think they did just showcase a couple of case studies which you can do. So if you have a big data problem, you should consider yourself to use the tools that have been developed by the data engineering community to optimize queries. And this is one case only that uses Impala and uses Parquet, all open source, and wrap it up together to constantly ingest DNS traffic. And open source the whole thing, the thing we've developed. It's all on the website. I would invite you to download and contribute as well. Next one, please. Yeah, we are constantly, using and developing more applications that benefit from that too. Yeah, and be happy to take any questions.
Any questions from the audience? Can I see Mike? Otherwise, I have some small questions. Well, one you just answered, it's all open source?
Yeah. Yeah, I mean, the whole thing is open source, and the changes we did, the things we did is also open source. Yeah.
And also about the data, how much of it also you can provide for example, for open access for researchers or even curiosity?
Yeah, so we have a privacy policy that defines what you can share, what you cannot, and how we can use the data. We provide aggregated data on our stats webpage, but providing to research, I think it's case by case. We haven't done that yet because it's pretty strict. They might be classified as personal identifiable data. So it's case by case. I think if you have an idea, just contact us and you see what we can do. Yeah.
Okay. And on your malicious domain research, you said that you take only the new domains registered per day, and then you classify them as malicious or not. Do you have any idea, or can you disclose any idea of the ratio between registered domains per day and how many actually are malicious?
So I think it depends a lot on the day, and per day you usually see like 10, 15 domains on average. And there's a bunch of some false positives too. And I think also depends on the definition of malicious.
10, 50 malicious.
Suspicious, let's say.
Suspicious.
And let's say, I don't know, depends on the day how many are going to be malicious, but there's a different definition of malicious. This thing detects based on the volume of queries. So phishing is one case, but there are cases that they create websites and selling counterfeit products like shoes or pharmaceutical drugs. So is this malicious? Is this illegal? It's kind of gray area. So there's a lot of those things too. So it's, yeah.
Borderline.
Yeah.
And one last question for me is, can you relate, it's similar to the question I had to Christian as well, can you relate the number of suspicious domain registration to certain events that go around the globe, or mainly in the Netherlands because of, let's say an example, I don't know, can be even Queen's Day in the Netherlands.
Yeah, I mean, we can see some stuff. I mean, we've seen a couple of politically motivated websites after some terrorist attacks that came up, and they kind of spread like fire on Twitter. And then, of course, you see these things next day in the queries patterns as well, because they go insane. So they can, if the domain is very popular on the first day, can be for different reasons, malicious or not, or like politically motivated or whatever. So it can be used as a sensor for that too. And so now we're actually working on extending this project to incorporate registration data to account for the likelihood of being like politically motivated. So rule out those kind of guys and remain only those that are actually trying to be malicious.
Okay. If we don't have any more questions, let's thank Giovanni again. Thank you for the presentation and for the open source. If you haven't signed the blue sheet yet, I don't know where it is at this moment, please do so. At the end, when we close it, I'll just bring it here, whoever has it, and then you can come here and sign if you didn't. I think it's it.
Yes. Thank you for having attended the NMRG workshop. As usual, we would like to ask you your opinion on the event, right, and also on future events. For example, we originally started several years ago that this kind of meeting was strictly on flow-based measurement for network management. And based on the feedback of the audience, we have extended that from flow-based, flow-based measurement to flow-based measurement. And this year we have extended to any kind of measurement-based network management. So feel free to give us your feedback, whether you like this direction, whether you want to have other topics in the next, probably next year's instance of the workshop. Do it now, or send us an email, or join the NMRG mailing list, right, which is of course appreciated. Anything else? There will be another NMRG joint event, right? Maybe you can say something on.
Yeah. Hello, everyone. Just commenting first on what Ramin said. So please join the mailing list and interact on the mailing list, and Ricky, if you wish, on this measurement monitoring topic of NMRG. Also, we used to have a combination of locating with IETF or the network management related conferences, so you can express also your views if you think this is consistent and if you want to continue this way. I will also encourage you to maybe try, as a community on this topic, try to define what will be some research topics, research areas, and maybe document that with some internet drafts, so that we also show that as a working group, as a research group, there is activity and maybe also a higher perspective to where this measurement and monitoring activity can go. Not talking about standardization, but as a research topic. And also maybe try in the future, maybe some interactions with, there is this MAP research group that has been recently created. They're also looking at measurement from a quite different perspective, but I think there is also a community there, also born to the scientific conferences. So maybe the two activities can also be have a bit more of interactions. That can be a topic for another either NMRG or MapRG joint session. And so what Ramin mentioned, there is a second NMRG joint meeting with NFV RG and NSDN on Friday morning. So it's the first morning session. The topic is on the managing virtualized and programmable networks. So we will have different kind of talks that are more oriented towards what are the challenges of managing a new type of environments with NFV and SDN, but also all these virtualization and programmable techniques can change a bit the way we manage networks. So please join this most interesting session we will have.
Yeah, just feedback, but Laurent already talked a little about that. Like the MapRG group is not really chartered yet, so I'm not sure what's going to happen in there. But just to make sure that's no more, I'm sure if it's the goals to have overlap or how you're going to handle if they go chartered. And they also started a workshop that took place on Saturday. So just to be aware that, you know, I'm not sure how to handle that.
We try to have some discussion with the chairs of MapRG, first to identify if the level of overlap and what could be the areas of collaboration, interactions. So since, as you mentioned, it's still developing in MapRG, it's not clear yet how two things can interact. But as you mentioned, we have seen that there were also part of the workshops. There have already had some meetings. So we see that things may grow there. So it would be nice to at least discuss all together.
Okay, thank you everyone for participation. Here are the sheets if you didn't sign. See you next time. Bye-bye.
Hello, I'm Costa for the Kutas. How are you? We have been discussing about this and I'm wondering